Hello, welcome to my first presentation on AI for cyber and cyber for AI. I chose the topic of artificial intelligence because it has become a buzzword. It's everywhere with tons of use cases. It is one of the most discussed and promising topic. While it is set to revolutionize many businesses, however, there are concerns of security, privacy, and the governance of artificial intelligence models. The objective of today's presentation is to demystify those concerns about security, privacy, and governance and present an abstract view of AI and security for AI. So let's quickly look at what we are going to see in today's presentation. The presentation is divided into two parts. The first part, wherein we are going to discuss AI, its quick overview, different models of artificial intelligence. We are going to look at the principles and the governance models, and then few business use cases. The second part of the presentation will focus more on security, wherein we will look at certain popular AI security frameworks, AI security controls, AI security testing, and publicly available tools for AI governance. So let's get started. This is a quick definition of artificial intelligence. We know that artificial intelligence is the simulation of human intelligence processes by computer systems, which means that it refers to human intelligence in machines that are designed, think, and act like humans. When we say that think and act like humans, it means that they can perform the same tasks which humans perform, that of learning, reasoning, problem solving, perception, and language understanding. They can also take decisions on their own. So these artificial intelligence systems work with the underlying data as the code. We know that when earlier programs were being developed, code used to be the key, which means that the way you code, the way the program behaves. It has workflows, it has coding procedures to execute certain tasks. But in artificial intelligence systems, it is the data that is being fed into a large language model. It learns, it can reason, and then through agents, it can take certain actions. Let's see and demystify the four broad pillars of artificial intelligence. It consists of four models. The first and broad concept of artificial intelligence is machine learning. Machine learning allows the computers to learn from data without explicit programming. Largely, you can divide machine learning into two parts, supervised machine learning and unsupervised machine learning. When we say supervised machine learning, it means that we are feeding the machine with labeled data so that it can learn. And then in unsupervised machine learning, the data is not labeled. The machine learns on its own. A quick example can be given that if you want machine to learn and differentiate between a cat and a wolf, you can feed the machine with various pictures of cats from various angles as well as of the wolf. The machine can quickly learn to differentiate between cat and wolf. In case there are errors, you can tune the model by human intervention so that the model can be more accurate and able to differentiate easily. But if it is an unsupervised machine learning, you are giving a lot of pictures of wolf as well as of cats. Now that there is no label, the machine can differentiate into set A and set B, wherein the set A can be all the models, all the pictures of cat, and set B can be of wolf. So that's the machine learning. You also have a concept of deep learning, which means that in deep learning is a subset wherein the machine learns like neural networks, just like humans. The second important concept is natural language processing. In natural language processing, it allows computers to understand, interpret, and generate human language, which means that it is a coder and decoder. While you can feed the machine with audio, text, video, pictures, graphs, etc., the machine only understands zeros and ones. But the output, which is the decoder output, has to be in such a way that it is in the same format that humans can understand. The basis of this entire NLP is the LLM model behind it, which is called as large language model. And you feed the data with tons of parameters and use models to decode and code and uncode what a human can understand. The third and important concept is computer vision, which enables the computers to interpret and make decisions based on visual input. What effectively means that you enable the machines to interpret and understand visual information, say, for example, to analyze the images and videos and extract meaningful information and make decisions. A classic example can be an autonomous cars, which has sensors to identify the path the cars the distances, the camera, and then take all this information to make certain decisions. The fourth and important concept of machine learning is robotics, which enables the computer to perform tasks autonomously or semi-autonomously. You can say it's like an agentic AI, which means that it has the capability to automate certain tasks without human intervention. The same example can be given here, sensors in autonomous cars. So what are the types of AIs? As we say, AI is a very broad field. It encompasses the development of computer systems that can perform tasks, requires human-like intelligence like learning, reasoning, and decision making. Treat it like a baby. As you speak, the baby keeps learning certain words. And then once it learns the words by repeatedly looking at the pattern and also the context, then the baby starts speaking. And over a period of time, the baby is in a position where it learns those words that it can articulate new words. So this articulation of new words and sentences is what is generative AI, which means it's a subset of AI that focus specifically on creating new content, which involves new text, new images, music, or media output. You take an example that you tell your chat GPT that I want a picture of myself in front of Eiffel Tower with a blue background and a river flowing beneath. Now, all of this information is already there in the LLM, but LLM generates a new data set, a picture of you, but with certain parameters that it already knows. And that's what generative AI is. Now, let's understand quickly two more concepts to make AI understandable. First concept is called as RAG, as we call it, repetitive, regenerative, argumentative, what it is. uh, hmm. All depends on quality of prompts, and to the RAG, you insert a query and you provide general listing. RAG is a framework that combines retrieval-based methods, information from LLM and source to validate the accuracy. Well, to understand the RAG, you understand that LLM is giving you information which is publicly available or trained, but it is not proprietary. Say, for example, you want to go to a hospital and you want to find it out whether the park is available in the hospital or not. Now, to know that whether the parking is available, you cannot query an LLM because LLM does not have that real-time data. In case if you do, it might either give you inappropriate or incorrect answers based on other parameters, maybe time, near hospital, or if there is a past data about that hospital or similar hospitals, or it will give hallucinated answers. So what you need to do is that you need to ask the LLM that if you get a prompt to identify any proprietary data, then you can go and connect to that proprietary data and get the information. Now, that proprietary data is typically available in something called as vector database, which means that there is a capability of the data to be uh, take content from websites or PDFs or databases and then stack it into a vector database, which compresses and then they keep the data into semantics and retrieves when a prompt is made. So you can also take another example. Suppose if you go to a airline flight and you want to know when is particular flight going to touch down. Now this information may not be available to the LLM, but once you query the website database or there is a chatbot that this flight company has provided to you, it takes this query and validates with the near real-time data. And it is also possible that the decision making or the most probable time of arrival of a particular flight can be combined not only with the query that when is this flight going to touch down, which might be a standard time of say 10:45 a.m., but because the weather is bad, it may tell you that the most probably time of arrival is 11 a.m., which means that it is augmenting or complementing that with additional data. Now let's quickly look at another concept, which is called as agents. SVC agents provide a degree of autonomy and can also make decisions or take actions on their own situation. The classic example of an agent is the autonomous cars, which have multiple sensors. They get data from cameras and they also understands when to stop, when to change lanes. And these are the decisions that the autonomous car takes on its own, obviously because there is an agent. So it's the agent which is taking the decision. It's not the workflow that is determining the action and reaction. So now quickly let's look at the three different type of AI models, as we call it, public AI model, which are openly available and anybody can access and use. For example, they are hosted on the platforms like Hugging Face or Global Google Colab. This allows the users to implement them in their setup with minimal setup. Then there are private AI models. Now, these are proprietary models which are developed internally by the organization, and they are not publicly accessible. They are tailored to a specific business needs. And the third one is a SaaS-based model. These SaaS-based models are offered as a service through cloud platforms such as AWS or Azure or Google Cloud. And users can integrate their services into these applications without really managing the infrastructure, and they get benefit of the scale. They do it by application programming interfaces. So application provide business process with AI technology. The second model is a leverage, which means that it's a kind of model where you put up a wrapper or your own model, wherein you do the bespoke development, which means that the entire application as well as the model is created by you. So let's look at some of the business use cases. And here I'm going to give the example of an insurance and your book ticket, term sites, provide prompt. Okay, let's see an example of AI use cases. Hmm. So there are various business use cases of AI. It can be used, say, for example, for fraud detection or algorithmic trading or transportation. And as we discussed regarding the agent-based AI, one of the classic example is this self-driving car. Another example is a traffic optimization, wherein the traffic is not based on the time duration, but it is based on the type of traffic, and they can collect this data by cameras, and they can see the data, and they can identify the optimum route and how much time really it takes from going from one direction to another, and then can control the traffic light signal. And there are many such examples. Most common use is of chatbots and virtual assistants, and Siri and Alexa are classic examples again of the AI business use cases that we can see. But let's look at one example, and we will be using this example in our presentation a lot to explain the concept that a health insurance company decides to automate the insurance claims which are less than 50,000 rupees will be done directly by the agents, and it will approve based on the data. Now, suppose this insurance has several parameters. It decides that based on the claim history, personal history, whether the claim is a firm or a corporate or a personal, what kind of hospital it is coming, and the bare minimum documentation that it needs, which means that there has to be policy, there has to be a doctor prescription, and there has to be a 24-hour of minimum hospitalization. And if there are any pre-existing diseases which are included or excluded in the claim. Now, based on these parameters, this automatically generates various algorithms, and algorithms decide whether the claim has to be approved based on these parameters or not. Now you need to train the large language model with, say, past data, and maybe you can take 2 or 3 or 4 years of data and can train and see the output that based on a particular hospital, which are very prominent hospitals based on certain people and corporates which take claims, and they do not have really the history of making claims which are denied. And then you can train it based on the diseases, etc. And then it can, or it has the ability to take decisions on its own. Now you want to reduce or replace and bring efficiency to the claim processes, and you want to maybe like 60-70% of the claims are under 50,000 or 1 lakh, and then slowly you want to extend it to 1 lakh and then take away the people that are required to validate, and you validate only the exceptions. Now, this is an example of AI use case that an insurance client can do. And similarly, there can be many other use cases that people can use to bring efficiency and bring down the cost. So let's look at certain AI principles. The first principle that AI should be transparent, which means customers must be aware about their association or integration with the AI system. They should be aware about the terms of use. And if you are using any of their data, it should be known to them. They should also be, there should be transparency in what kind of algorithm, what kind of data is being used, that is being driven. So it should be transparent to user, or it should be transparent to the regulator in case if it's a proprietary data, you are using it for a particular purpose. Then trust, which means that it should have a data security and privacy, and also the agility of the platform against the cyber threats. So be it data poisoning, or you're using private data, to learn, and then there is a probability of private data getting disclosed, or you are using your intellectual property rights. It should comply with regular regulatory and policy compliance. There are already compliance requirements like an EU Act, which ask AI uh, disciplines or AI use cases from the businesses to ensure that they are complied with security and privacy and fairness, and remove biases. Otherwise, they can be penalized anywhere between, say, 5 to 30 million pounds or euros, and in some cases, the penalty is into certain percentages. Then you have integrity, wherein you are checking the algorithm integrity and data validity, which includes data lineage and appropriateness. So what does this integrity means? That the data that you are using should be clean, it should be complete, it should not be tampered with, it should not have a data poisoning, and the data should be valid. It should not be very historical data or artificial or synthetic data that you provide for the system to learn. When we say data lineage, what does it mean? Data lineage, it means that you have the capability to track the data all the way to the source. So the data sources has to be trusted, and from where you have got this data all the way to the output, where you know that how the processing or pre-processing integrity has been carried upon. Fairness, which means that effort should be made to make sure that the data is as much fair as possible and it is protected with the attributes for the use. And then last is explainability, which means that whatever models you are using, it should be explainable, that how input parameters are generating outputs and what algorithms are getting used. So they should be consistent also, so that you know that they are free from biases, and every time if you provide similar kind of input, they get similar kind of output. Now we'll quickly look at let's AI governance. So we run into several issues, the source of data, whether do we trust the data, which model is being used, is it free from biases? Hence, it is extremely important that we create an AI governance model in which it is very clearly defined that how we are going to comply with security and privacy, along with the principles of AI security in various kind of AI use cases or models that we are going to deploy. So this is a quick, I would say not say model, but hierarchical stacking about AI governance. So AI governance, it means that how the AI is going to be used, how who is going to approve the use, and what kind of AI models we are going to use. So let's imagine that if you there are various business functions, and then business functions have various use cases that they want to use for AI. Then there has to be a process in which these use cases, based on the business cases, should come to a particular, say, AI governance council. An AI governance council can comprise of people from legal, from risk and compliance, from security, and from business heads uh, perspective, so that they can understand the business case for use of AI and ensure that it is appropriately assessed for risk. And then there are controls from security, privacy perspective. And if there are AI ethicists, they should also be a part of this governance council. So what should we do? We should create roles and responsibilities for this governance council, which is comprising of business functions, technology, cybersecurity, legal and compliance, and AI ethicists. We should also have a policy that governs the use of AI and directions about how the AI controls will be used, be it approvals, be it periodic monitoring, be it reporting, etc. Then, or a period of time, we have to also do risk management, which means that we have to assess, depending on what kind of AI we are going to use and what kind of controls the AI has. And then finally, monitoring, which means that monitoring the AIs for usage, biases, availability, risk, and compliance issues. Regulatory bodies also worldwide are currently developing requirements for organizations to ensure the trustworthiness and security of AI. For example, the EU's AI Act requires now providers of high-risk AI systems to implement governance and accountability mechanisms, which includes confirmatory testing and certifications. So design philosophies should incorporate the requirements set by these impeding regulations. So now let's look at the different models that are available. One of them for the models that is used for security framework is Databricks. And you can see that this is a picture that is proprietary to Databricks, and they have published it publicly. I have provided the link. You can go back and this video and even download the framework. So you see that the first part or the entire part is divided into four parts. The first part, which is here, is governance. Yep, this one. The governance part, and this is data ops, this is model ops, and this is basic ops. So these are the broad four categories that have been divided. So the first one, let's quickly look at the data ops, which consists of raw data and the data prep that you can see. So what does raw data means? Which means that for an LLM model, you can have various data sources. It can be a structured database, it can be flat file systems. The data can come from certain APIs from third-party sources, or the data can come from certain websites or certain files, etc. So you gather data from various sources. It can include sensors too. And then you prepare. Now, what is preparation means that the raw data may not be in a position to be used completely. So you clean the data, which means that you pre-process the data to extract, transform, load. Once you extract the data, you put it in a particular structure, and then you also handle the issues like there are certain missing values or there are certain outliers, and you also normalize this data. And then what does EDA means, which is exploratory data analytics, which means that you provide EDA to uncover certain insights or trends or relationship within the data. And then you create data sets by training the data using various algorithms, by validating this data, and then using human intervention to remove biases, provide certain synthetic data or change weightages to ensure that this data is appropriate, and then test this data. Then the second point that comes is about the model. And that what does the model means? That you are training the model using the predetermined data sets. Maybe you are tuning hyperparameters for optical performance. Then you are also using deployment, which means that the model has to be deployed into the production environment and it should integrate with the existing systems. Then the third concept is about algorithms, what kind of algorithms you are selecting, and what kind of techniques you are using, be it classification or regression. And then evaluation, which means you are assessing the models with the validation techniques using data sets with metrics like accuracy or precision or recall value. And finally, you are also seeing certain external or custom models that you are going to use depending on the algorithms, and you fine tune and pre-train the model. And then you can also see the concept, which is called here is cataloging. And what does cataloging means is that you create a catalog of data sets that is can be used in training. So, for example, if your data catalog, if you can have a model catalog where you are having the full information about all the data sources that is being used to train the data and evaluate the data. Similarly, you can have a model catalog wherein you know all the different kind of models that you are going to use. And on top of it, you have governance so that you implement the policies for both data and model management and ensuring compliance with the regulations. Finally, the DevOps, which means that this is the APIs or application that you are creating. Maybe you are creating certain RAG models there for decision making. You are creating an interfaces where users will query. So there are prompts. And then these are the infrastructure on the server side and the application and code that you are developing so that they can serve the user with the prompts and take the interface. So the last part you can see is monitoring, which means that you do the CI/CD and the monitor, which means continuously monitor the model for performance of data quality, and you do the regular maintenance. Integration of all the components is important because this AI lifecycle is really iterative and it has various feedback loops for each component. So for examples, you can get insights from monitoring and you may prompt for the data collection or a model retraining. So collaboration among data scientists, data engineers, and DevSecOps teams is really critical for this entire model to work. So this comprehensive approach ensures that systems are robust, maintainable, and capable of delivering value over a period of time. Now, now that we have seen Databricks model of security, there are various other models. You can go and look at the six principles of Google's AI safe SAIF. From the security risk perspective, you can also look at OWSP's top 10 security risk, and you will find that those risks will fit into it because they are either model risk like data poisoning, it can be a API security issues or model management issues like model inversion, or it can also be an issue of model stealing. So you will identify that. Now let's quickly look at the security controls from the data security framework. As we saw earlier that the entire uh, model is divided into four parts: data ops, model ops, DevSecOps, and then operations and platform. So we'll look at the security risk also from that. Now you can see that there are certain set of numbers that have been provided. Like for example, in the raw data, there are 10, which means specifically that there are 10 risks which are identified. There are four risks which are identified in data prep. So altogether, somewhere around 55 odd risks have been identified, and then there is a control catalog to be implemented, to manage those risks. So let's quickly look at it. So let's start with data operations. In data operations, you see risk from raw data, data sets in data preparation and data cataloging. So first you see that there is a lack of adequate data access control, which means that we do not know from where we are getting this data. So it's important that your data sources are trusted. You know what kind of data you are going to get. And then you also have certain data access controls like encryption or tokenization. It's specifically important if you're getting a lot of private data, that you tokenize the private data so that the private data does not go into the model. You can also classify the data so that based on the classification, the LLM can learn. And there can be some data which you do not want your LLM to learn. So you can classify so that that data is not used for learning. Then not having data classification and governance, as I said, that classify the data, what can be used to learn and what is the sensitivity of the data. Then exposure to data poisoning, missing data lineage. Data poisoning is self-evident, which effectively means that you can poison the data by providing inappropriate data or incorrect data. We saw the example of an insurance. Now, suppose in the insurance uh, pre-approvals or auto approvals, there were 8 parameters, and one of the parameters was the hospital, and the hospital is a very prominent one. You are generally approving the claims coming from those hospitals, of course, subject to the all other parameters. But if you poison the data, which means that you provide lot of inappropriate or failed uh, claims from the past history of that particular hospital, then you are also letting, or making the model learn in different things. So that's a data poisoning. The lack of pre-processing integrity. What does lack of pre-processing integrity means? That pre-processing includes numerical transformations on data aggregation, text or image encoding, and new feature creation. Now, this can be followed by combining different data like joining tables or merging data sets. Data preparation involves cleaning and formatting the data, which means that how to handle the data, how to ensure missing values are there, ensuring correct formats and removing unnecessary columns. Then you have adversarial partition, feature manipulation, which is self-explanatory. But label flipping is another concept wherein the attackers manipulate the label of a fraction of data. In these attacks, the attacker changes the labels of a specific training point so that you can mislead the ML model. Let's go to the model operations. Here you see risks which are coming from the machine learning algorithms, evaluation of the models, how the model is built and how the model is being managed. So in this case, you find hyperparameter stealing, which means that confidential parameters getting stolen from the model by making either bots or putting up a lot of recursive queries so that you can get the information about certain confidential parameters. Then you have model attack, evaluation of lack of tracking and reproducibility of experiment. This we explained, earlier, where lack of tracking and reproducibility of experiment means that data has to be consistent every time you provide the prompt. It should generate a consistent response, and you should be able to track the data, which is a concept of a data lineage, which means that you go back and see that whether from the output all the way to the input, the data is consistent, whether it is getting transformed or from which data source it is coming. So then we have backdoor machine learning or a Trojan, which means that we are trying to influence the model. We have asset leak, model theft, model inversion, and then lack of model management. So let's quickly look at one by one. Data poisoning attacks, as we say, that it's a contamination of the training data. It takes place during the training time of the machine learning. An adversarial can try to poison the data by injecting samples How do you protect against it? You can monitor to access the training data and also to the production data. Prompt injection, adversarial examples, you can ask sensitive information. You can infer training data membership, output manipulation, and then model extraction, model breakout. And the fourth one is the operations, wherein you verify the machine learning algorithms, model build and model management. Here you have lack of MLOps or repeatable security standards, which means they do not have a governance. You do not have a model security policy that you can apply consistently. And then your platform might be at risk. You are not doing enough vulnerability assessment or pen testing. You do not have an incident response or network access controls to control and then software development lifecycle practices for security, be it secure APIs like having encryption, authentication, authorization, tokenization implementations, etc. Now that we have looked at the different security controls, let's look at the AI security, wherein you define certain controls to protect us from threat and vulnerabilities. So data protection, we looked at the encryption, whether we use advanced encryption techniques to protect the data at rest and in transit, and you anonymize the data. Then second is the model trainings, wherein you develop strategies to protect the model from various attacks. We saw there are various types of attacks, be it model stealing, model inversion, data poisoning, and then model hardening. Then access management, where we talk about authentication, multi-factor authentication, data coming from the right sources, and the sources trust by using certain APIs or making system queries which are governed by, say, authentication and authorization. The data should be encrypted so that the sources are giving the data appropriately, etc. Authorization, wherein you define and enforce strict user controls and permissions, who can access the model, who can really do the governance, who can set up the policy, who can control the trained data for fairness by either providing synthetic values or changing the weightages. Then you have strict controls on monitoring and auditing, wherein you continuously monitor AI systems for unusual activity and performance. We saw various types of attacks in which you can monitor and identify whether it is coming from bots, like by understanding too many prompts coming from the same source, or by just changing one of the parameter out of the eight parameters. So to try to understand the model for stealing. You should have audit trails, which means that you should maintain detailed logs of all the accesses as well as the queries and to ensure compliances. Then you have bias and fairness check. You can regularly analyze the model for biased outcome, use fairness metrics, ethical guidelines, and then you have robustness testing. So for stress testing and scenario analysis, and finally the incident response planning. With that, I will conclude my first session. What we have seen in the first session is about the Databricks security framework. You can also watch the Databricks security framework along with downloading it from the link that has been provided below. You can also watch their detailed security video in the link that is provided. I'm going to upload this presentation onto the website. So if you require, you can download the presentation from here. In next 2 days, I will see you in session 2. Thank you and have a great day. Don't forget to like, share, and subscribe, and also press the bell icon to stay notified of all the future released videos. See you in the next one. Thank you.